In this set of videos, we're going to continue our discussion about differential equations, and we're going to talk about slope fields. Alright, so before we talk about slope fields, just remember things about slope. So remember that our derivative is the slope of the tangent line to our function. Alright, so it's our derivative is always representing a slope to the original equation. And what can we say if we know things about the slope? Well, the slope is positive. We know that our tangent line has to be going up that direction. If our slope is negative, it has to be going down in that direction. If our slope is 0, it's flat. And if our slope is undefined, it's because it's a vertical tangent. Alright, so these can all help us if we know some values for our derivative. We can kind of plot tangent lines and figure out what our original graph is going to look like. Alright, so just imagine I had this differential equation. The derivative of y with respect to x is equal to this expression. Well, I could just plug in random values for x and y and figure out what the slope of the tangent line would have to be at that point. So for instance, I could plug in the point 0, 0, and that's going to give me dy dx is negative 4. So when my graph is at 0, 0, I'd have to have a tangent line of negative 4. I could say plug in 1, 1, and that'll give me 5 minus 4 is 1. So when my graph hits 1, 1, the tangent line has to be 1, so it's going to be this upward slope like that. And I can do this for every single point. Generally, you're just going to do it for the whole number values, but you can make a computer do all of this really quickly, and then you can get something that looks like this. Alright, so this is a slope field for this differential equation. So you can see at 0, 0, the one we plugged in, you get this downward arrow, because at 0, 0, it would have to have a slope of negative 1. And I'm not exactly sure of the scale here, but for 1, 1, we got positive 1. That looks like it'd be about here, so the scale must be halves, because that looks like it's positive 1. So when I plug in 1, 1, I get that positive 1 slope. It's an arrow going up. So for all of these values, I get kind of the direction of which, or an arrow pointing to the direction that my graph would have to go at that point to satisfy the slope of the tangent line. So what we're going to do in this video is just make these slope fields ourselves. We're not going to make ones this detailed because that would take forever. You can make the computer generated ones, but we're going to do the same idea, just making our own slope fields. Alright, so we have the differential equation dy dx equals negative x over y. And we have about 25 points to do, so we're going to have to use some help to make it go a little bit faster. Alright, so for every single one of these points, we want to plug in the x value and the y value to get our slope. So let's start with 0, 0. If I plug in 0, 0, I get negative 0 over 0, and that is undefined. And I definitely don't know if it's which direction it's going to go. So that one I'm just going to leave. Let's try 0, 1. If I try 0, 1, I get negative 0 over 1, and that's 0. So 0, 1 is 0. So that's going to be a little flat tangent line there. 0, 2 would be the same thing. It's 0 over 2, so that's also going to be a flat tangent line. Negative 0 over negative 1 is still 0. So when x is 0, the whole thing is just 0. What about when y is 0? So I'm going to try 1, 0. Then I get negative 1 over 0. And that's undefined. But that's undefined because it's going to go to infinity, and that's going to give me a vertical tangent. And it's going to happen whenever y is 0. Alright, then all the other ones we just have to kind of plug in values. So I plug in 1, 1. I'm going to get negative 1 over 1. That's a negative 1 tangent line. 1, 2 is negative 1 over 2. That's a negative 1/2 tangent line. So that's 1, 2 is there. Negative 1/2. What's the next one? 2, 1. It's going to be negative 2 over 1. So that's a sharper down tangent line. And then 2, 2 is negative 2 over 2 is also negative 1. So you get the idea. I'm going to kind of pause here and just go through and put all the rest of them in. That way you don't have to see me do all these kind of simple calculations. Alright, and this is what I got. So I kind of put all the values for the second quadrant, the top left there, third quadrant there, fourth quadrant here. Alright, and you get this slope field. But again, for every single point, I basically just draw a small tangent line to represent what my graph would be doing if it hit that value. And we'll talk more about how to kind of use these slope fields in the next video. All right, so we'll do another example. Again, let's start off with some simple points. So let's just start off with like the points on the xy axis. 1, 0, 2, 0. Let's try some on the y-axis. 0, 1, 0, 2. So I plug in 0, 0, I get 0 minus 0, and that's 0. 0 minus 1 is negative 1. 0 minus 2 is negative 2. 1 minus 0 is 1. 2 minus 0 is 2. All right, so right away I can get these small tangent lines. At 0, 0, it has slope 0. So when it hits that point, it should be going flat. 1, 0 should be at negative 1. 2, 0 should be at negative 2, so steeper. 0, 1, it should be at 1. 0, 2, again, it should be steeper. All right, so again, just plugging in values, and for each one, just drawing a very small line to represent that tangent line. I can do, again, let's look at, kind of separate into the 4 quadrants. All right, in quadrant 1, I could do stuff like 1, 1, and I could do 1, 2, and 2, 1, and 2, 2. All right, so when I plug in 1, 1, I'm going to get 0. 1, 2, 2 minus 1 is 1, negative 1, and 0. All right, so I'm going to get some more tangent lines. So 1, 1 was 0. 1, 2 is 1. That's going that way. 2, 1 is negative 1, so it's going down because it's negative. And 2, 2 is 0. All right. All right, again, you get the idea. So now I'm just going to kind of go through and put all these values in. That way you don't have to watch me do all these calculations. And you get this as your kind of final slope field. So you can see the kind of breakpoint is on this diagonal. They're all 0. Above that diagonal, they're all kind of going upward. Below the diagonal, they're all going downward. So there's always these little patterns to these slope fields. But again, it's just plugging in a bunch of numbers and seeing what you get. All right, so here's one for you to try on your own. All right, try to find the slope field for dy dx equals x times y. All right, you should get a slope field that looks something like this. Again, you're just multiplying, so anytime either x or y is 0, you get that horizontal tangent. And all the other ones are in quadrant 1 and 3, they're positive, so they're going upward. 2 and 4, they're negative, so they're going downward. All right, but that's all you need to know for now. For slope fields, you're just basically plugging in a bunch of numbers, all right, every single kind of nice number into your differential equation. For each one, you're just making that tiny little tangent line to represent if my graph was hitting this point, that's the direction my function would be going.